This is a video for Advanced Algebra 1, Topic 3, Section 2, linear functions. And basically we're going to be looking at the same things that we did with linear functions in Topic 2, except we're going to change the notation to function notation. So function notation is just a method for writing variables as a function of other variables. The variable y becomes a function of x, meaning that the variable x is used to find the value of y. And that helps us distinguish between different functions. And I've already talked about this in class, that some examples of function notation for revenue. Sometimes we use R of t, cost, profit. These function names, rather than just y equals, gives us an idea of what equation we're looking at. We're looking at a revenue equation, a cost equation, a profit equation. And we talked about in physics, S of t is used for position. V of t is used for velocity. A of t is used for acceleration. J of t is used for jerk. And then that way, the functions take on meaning again, rather than just y equals, and trying to figure out which one is which. So at the beginning, we just practice with the notation and get used to using f of x. But what does f of x really mean? It means that that's the other variable. Okay, so f of x equals 2x plus 3, because we're going to focus on linear functions. That's what we know right now. This is just the same as y equals 2x plus 3. And we know the y-intercept is 3, and that the slope is 2 of that line. And then we use function notation. Let's say I want to find f of 2. And so I plug in 2 for x and solve that, and I get 7. So that's actually the ordered pair 2, 7. So function notation works, the same way as what we've been doing. So what the book likes to talk about is that we have a function machine, and our function machine looks something like this. And inside our function machine here is the equation 2x plus 3. And so we plug in, let's plug in -5. So we plug that into our function machine. We take 2 times -5 and get -10 plus 3. And what comes out of our function machine is -7. So again, that's the same as the ordered pair -5. That parenthesis there, -5, 7. Okay, or we could have also written f of x equals 2x plus 3, and so f of -5 is 2 times -5 plus 3. This notation is a notation we need to get used to. And that's exactly what the first homework problems are like in your online assignment. They're giving you f of x equals -2x plus 3, and they want you to find f of 2. So f of 2 is -2 times 2. Let's see, that's -4 plus 3 is -1. And they want you to find f of -2. So let's see, f of -2 will be -2 times -2 plus 3, or 4 plus 3, which is 7. Then the other thing they want us to do is to write the equation for linear function using function notation. For using function notation, we have to be in slope-intercept form. And none of the other ones, you know, this is y equals mx plus b. We use f of x in place of y. You know, no other form, point slope form or standard form, lends itself to that notation. So if they want us to find the linear function that represents the data in this box, this is just like saying, okay, here's your ordered pairs. Your ordered pairs are 1, 1. This ordered pair would be 2, 4. This one, 3, 7, 4, 10. And from that, we only need 2 points to find the slope. So the slope is 4 minus 1 over 2 minus 1, which is 3 over 1, or 3. So y equals 3x plus b. Now I plug in any point there, doesn't matter which one. Let's plug in 4, 10. So 10 for y and 4 for x. And we get 10 equals 12x plus b, not 12x, 12 plus b, then subtract the 12, b is negative 2. So, you know, the previous topic, we would just say, okay, y equals 3x minus 2. But we're in functions now and dealing with functions, and so we want to use function notation. So instead of y, we're going to say f of x equals 3x minus 2. Or we could say g of x, or h of x, or q of x, or whatever of x you want. Okay, this particular one, I kind of stick with that. And that's really all we're doing. You know, plugging in numbers to find values, and then using values. They may have you do some graphing from this, which is the same thing. You know, to graph this, that's your y-intercept, that's your slope. So put this point on the y-axis, go up 3 over 1, draw the line. And, you know, it's everything that we've done in the previous chapter, previous topic. So that's it.